Types of special segments in triangles. So we're going to talk about 4 different types of segments. The first one is perpendicular bisector, which is a segment, ray, etc. that passes through the midpoint of a side of a triangle. So when you draw all 3 of your perpendicular bisectors, they're going to intersect at a circumcenter. There are 2 theorems that you should know with this particular type of segment. The first one is 5.1 and the second one is 5.2. 5.1 says any point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. The second one is any point equidistant from the endpoints of a segment lies on the perpendicular bisegment of the segment. So I'm just going to show you an enlarged figure of the one that you have. So you have this line 2. It intersects at this point of concurrency called the circumcenter. This line is perpendicular and is in the middle of this particular side AC. Your next type of segment is angle bisector. So an angle bisector is a ray, a segment, that cuts the angle into 2 congruent angles. So when you have your 3 angle bisectors, they all intersect at what's called an incenter. It's equidistant from each side of a triangle, and so forth. You have 2 different theorems that you should know. 5.4, any point on the angle bisector is equidistant from the side of the triangle. And 5.5, any point equidistant from the sides of an angle lies on the angle bisector. So I'm going to go through. Just look at this figure here. It shows your 3 angle bisectors, and you can see here that you have tick marks indicating that these 2 are equal to each other, as well as here and here. Third is median. This is my favorite. A median is constructed from the endpoints that one is a vertex and the other is the midpoint of the opposite side. You then have this point of concurrency called the centroid. A centroid is 2/3 of the distance from the vertex of your triangle to the centroid, to the opposite side. So here, from C to that centroid, this distance is double O to D. So this here is 2/3 of the whole thing. So this is double that part. So I'm just going to show you a larger segment here. And we know that theorem 5.7 says that a centroid is located 2/3 of the distance from the vertex to the midpoint of the opposite side. So here, if this was 6, this would be 3 from here to here. Last but not least is an altitude. We're going to be constructing these as well. The point of intersection is a orthocenter. Okay. So an altitude is constructed from the vertice and is perpendicular to the side that's opposite. So we just have a definition here to know. A segment from a vertex to the line containing the opposite side and then perpendicular to the line containing that side. So from the vertice to the opposite side, it's perpendicular. I'll just take a look at the larger figure here. So here you've got your first altitude, second, and third. These all intersect at an orthocenter.